histograms. Example 5. So we need to give a reason why a histogram is appropriate to represent this data. So for a histogram we need quantitative continuous data, and we're looking at distances in kilometers. Part B, we have to calculate the frequency densities needed to draw a histogram for this data. So we're not doing the actual histogram, we just need to calculate the frequency densities. So frequency density is frequency divided by class width. Well, these are the frequencies, but the class widths are not based on these numbers. We've got rounded data. So that's 45 and there's a gap because that's 46. So we need to make some adjustments here to work out the class boundaries. So lower class boundaries and upper class boundaries, giving these particular class widths. These are the frequencies, so frequency divided by class width will give us these frequency density values. Example 6. So there's no scale given here for frequency density, but we do know that 5 squares is 1 centimeter. And 1 centimeter represents A units, and we have to work out the value of A. The total frequency is given for the histogram. If we work out the total area in terms of A, we can easily work out the value of A. That's 5 squares, that's 1 centimeter, because 5 squares is 1 centimeter. And 1 centimeter represents A units, hence the A. So that's A, then that's 2A, 3A, 4A, and 5A. And then we calculate the area of each bar. So for instance, this bar here, the width between 20 and 40, that's a width of 20. And its height on this scale now is 1.4A. So if you multiply them, so you've got class width times frequency density, you get frequency. So if you work out all of these, you'll work out the total area and you'll get an indication of what the total frequency is from the total area. So there was 160A altogether, which represents a frequency of 800. So 800 divided by 160 gives us 5. So A is equal to 5. For practice, try these questions.